Hey everyone, Internet Book Reader here. Today I want to talk about special relativity and classical field theory by Leonard Susskind and Art Friedman. Yes, you might realize the author name Susskind among us. And also you might think, are you underqualified to review this book? Why, yes I am, but in my defense, this book is based on theoretical minimum online courses that Leonard Susskind made, which is a series made in Stanford. And the book itself is written along with Art Friedman, who is his student. So it's a kind of journey for not only Leonard Susskind teaching Art Friedman, but also vice versa, where Art Friedman are learning from Leonard. And this is actually the third book in the series. I don't know if the first two books are a requirement to understand this book at first, but nevertheless, as the title suggests, this is a book explaining special relativity and classical field theory, which is a study that I don't even know is an entirely different study to general relativity. So you know how underqualified I am. The history of the study itself dates back to 19th century, where Michael Faraday made the foundation to electromagnetism, and from that, Maxwell discovered displacement current and constructed the first true field theory, the theory of electromagnetism. But Maxwell's theory is that light is constant, which is at odds with Galileo and Newton's theory that all motion is relative, because on paper, light that stays at the train station should move at a different speed than light that left the train. So at the time, the resolve itself is using imaginary substance called ether that will resolve this conflict. Thankfully, in 1887, Albert Michelson and Edward Morley did some experiments and failed to find evidence of ether. It was not until 1895, when Einstein was at the age of 16, just 16, that he starts to experiment using two principles. One, the laws of nature are the same in all frames of reference, thus there can be no preferred ether frame. 2. It is a law of nature that lights move with velocity c. A decade later, that theory will become the paper that contained the special theory of relativity. What especially made this paper special is that Einstein added that the speed of light is the speed of light. It is a constant that have the same velocity no matter the condition on how it is viewed. Which does not make sense, because if you see a moving train by chasing it using a car, and when you see it by just standing in the train station, the speed of the train should look different. But somehow this observation does not affect the speed of light, whether you're observing it by standing still or chasing after it. Somehow the speed of light still looks the same despite the circumstances on how you're observing it. Some scientists even rejected special relativity because of how nonsensical it is, until all experiments done on it only prove it to be correct. A lot of this explanation on moving frame is done using this space-time diagram to find or coordinate on how time moves in certain space to understand relativity better. It explains why we as material cannot move faster than light. It explains the paradoxes that resulted in aspects of general relativity, like length contraction and time dilation, the twin paradox where your younger self can look at your older self, Minkowski word about invariant, an aspect of space-time where its quantity doesn't change no matter where you look at it from. The first chapter will make sure to hammer our understanding of space-time so we can separate at least time-like, space-like, and like-like. Then in the second chapter we'll add velocity to them. And in the third chapter we'll look at Newton's relativistic laws of motion. This, I think, is one of the most important topics discussed in the book. Because of Einstein's special relativity, a lot of physics, including laws of motion, force, and acceleration, has to be rebuilt all over again since they're a bit lacking now. This chapter will talk about kinetic, particle mechanics, Lang gradient, mass of particle, energy, etc. And it will close the book with the classical field theory, where we look at Lorentz force law, waves and waves equation, the study on water wave, light wave, sound wave, weight made of guitar string, etc. Then we also look at Maxwell electromagnetic, where we study even more in-depth on the laws of electrodynamics and conservation of electric charge, which I'm sure someone like Electroboom is much more familiar with. We even go to field energy and momentum, learning the three kinds of momentum: mechanical, canonical, and no ether momentum. Even Brian Cox books I reviewed a few months ago is Quantum Physics, a study of when things are very small. Then this book about special relativity is when things go really fast. The book did mention this and also said that it should be easier to get into since special relativity math and explanation is less abstract than quantum physics. And that's exactly what we'll try to go through this book. Unfortunately, the book title kinda lied to you, where this book is not exactly a book for minimum theoretical knowledge, unlike Brad Cox and Jeff Dunham's book, where the authors are trying to convey the meaning of the theories inside them using words. Here, the author sometimes just gave up on using English and instead used math for most of his explanation. You guys won't feel this because my upload is still very constant, but I was on a 10 days holiday when I'm reading this book slowly, and every time I showed my friends and family the pages of the book, they got jump scared by all the maths. But don't worry too much about the math if it's possible. It's mostly just explanation of the formulas without any actual math done, where we'll need to actually calculate number. No, we don't need to do that. But still, even with just the formulas, it immediately isolates most readers that don't have enough understanding in algebra and calculus. Although to be fair, the author still explained them well enough, so even someone like me whose math skill is only as far as the calculator app in my phone can still understand parts of the book. And since this is the third book, which I'll admit is my mistake for skipping the previous books, it has so much reference to especially the first book that kinda makes you feel like actual algebra class where you miss one class and suddenly it's a whole different world you're listening to. Although the book might not realize this, but it is a more advanced look into general relativity and classical field theory that I don't think will appeal to most people. But if you're someone who are interested in a more advanced read to the topic, this will be the book to get, I think. The explanations are clear, albeit very complex, and it has some humor in it, even if they're old men teaching in class kind of humor that's a bit corny. But it is honestly a fun read despite all the migraine I get from it. I just wish the author took his time explaining how to read something like this from the book, and I wish the book didn't outsource their explanation to look it up ourselves since people paid for the book. How do you spell the X and the X with the little thing on top? I had to look it up myself, and that the 0 and 1 etc. on the top of the X is called exponential. I had to look it up because my understanding in reading math symbol is only up to squared, which is 2, and that's from E equal mc squared. And if I cannot read most of this, how would I fully learn from it? I mean, I only know that the symbol is phi from watching Kamen Rider Vice, and the formulas I can kinda understand are the ones where I can say out loud the formula and understand what they are, not just some strings of random letters and symbols. So it's really a shame that most of these are not in the book. But besides all that and everything I've mentioned, there's still so much more I've learned from this book. I know why Planck made the speed of light as equals 1, and why Newton's gravitational constant is also set to equals 1, that tensors apparently have ranks in them. I learned that there are 4 fundamentals to special relativity and classical field theory: the action principality, locality, Lorentz invariance, and Gauss invariance. And most importantly, I learned that these theories are not just made by Einstein. There are countless people that worked on it. There's Newton, Ampere, whose name we're very familiar with since Ampere is named after him. Then there's Faraday, Maxwell, Wheeler, Lagrange, and there's even Oersted, not the one from Musso Potenzae, but from Dennis, and many others. Countless of people have worked on this to further our understanding of the world and the universe, and our technology benefited so much just from these theories, and countless other people that are far smarter than me will continue to test and advance these theories. People like the authors and their students that even left us a nice message at the end of the book for reviewing these books. For me personally, I give this a 3.25. What do you think? Are you gonna read it? Did I miss anything? Leave your thoughts in the comment below and subscribe to the channel. That's about it.